All right, in this part 3 video, I'm going to be going over 14 through 21. All right, and so 1 through 13, as you've watched hopefully already, and we did in class, is essentially just focusing on finding the area between two curves. So in this video, we're going to be focusing on the other aspect of this unit, which was an application of integration where we integrate the area to find the volume. So we're usually going to talk about this area, this region R, being revolved around one of the axes, and then we use that integration of the area to find the volume of that whatever is made. Okay, so we have this region right here, R, is in the first quadrant, bounded by the axes. The horizontal line, right, this is y equals 1. That's y equals 1. And the graph right here, this curve, is y equals the natural log of x. What is the volume of the solid generated when region R is revolved around the y-axis? So right out of the gates here, the very first one is already getting a little confusing because we are going to be revolving around this y-axis. So the way you want to do this first is if I'm revolving around a vertical axis, when it says y equals our function, we actually want to get that to be x equals. So the way I'm going to do this is I'm going to rewrite it. Right, this is the base e, and if you remember from your days in algebra, if you swoop e to the power of y equals x, so e to the power of y equals x, now I can use this as my function when I want to integrate the area. So to find the volume, do pi times the integral from 0 to 1. Remember, you're going vertically here for our limits of integration, right? 0 to 1. And then we have our function, which is e to the power of y, all of that squared, dy. All right, so I'm going to integrate this to find our volume. All right, if I go ahead and raise that to the second power, I get e to the 2y power dy. All right, then I'm going to do the antiderivative, which means copy it. All right, but when I take the derivative of this, I would have to take the derivative of 2y to get 2, and I don't want a 2, so put that reciprocal in front, and we're going to evaluate this at 0 and 1. Now remember, right, a lot of times 0 makes me happy because then I don't actually have to worry about plugging it in, but with e, you definitely need to. It's 1 half times e to the 2 times 1 power minus 1 half times e to the 2 times 0 power. So this is going to be 1 half e squared minus, and this one I've got e to the 0 power is 1, so minus 1 half. And then remember, all of this needs to be multiplied by pi. So that's my answer. That's what I'm looking for. I'm looking for the solution that matches this. And it looks like the only one that has all that together would be e squared minus 1 divided by 2 if you factor out the 1 half and put it in the denominator as a 2, and then the pi out multiplied in front. So the answer is B. That's it for 14. All right, let's try 15. Okay, 15 says R is a triangular region. We got to do a sketch here. In the first quadrant with vertices at 0, 0. Well, we know this one is 0, 0. Then we've got A0. So this is A, comma 0. And then this is 0, comma B. And this is a triangle. Okay. We are going to revolve this around the x-axis, so that's kind of nice. I don't need to worry about any term like changing the function in terms of solving for x. So we're going to have dx as our answer. And the first thing I notice is we're going from 0 to a. So I'm crossing out a and I'm crossing out c because those are not going from 0 to a when you're revolving around the x-axis. Okay, so really the main question is what is this function? Well, it's a line. So if I want to write this, I'm going to think slope-intercept form, right? So let's go ahead and get the slope. The slope is the change in y over the change in x, so b minus 0 over 0 minus a. So my slope is going to be the opposite of b over a. All right, and then my y-intercept is whatever b is. So this function is going to be the opposite of b over a x plus b. So if I look in my answer, I'm looking for this inside, and I'm looking for it to be raised to the second power. All right, and it looks like the only one that has this is letter D. that has that correct slope and y-intercept, all of that squared. And that would give me the area, and then we integrate that to get the volume. All right, so that's it for 15. 16. We have the volume of a solid generated when the region in the first quadrant bounded by this graph, the x-axis and the vertical line, x equals the natural log of 2 is revolved around the x-axis. Okay, so I don't need to do any changing there, so that's good. All right, so we've got, let's plug in 0. E to the 0 power is 1. All right, so that's 0, 1. And then we care about this line, x equals the natural log of 2. Now, I don't actually know the natural log of 2, but I know it's some number. All right, and e to the x looks like this. All right, it looks something like that. So I just need to figure out in terms of this point, right? I actually don't figure anything out. All right, I don't know. I could, if you wanted to find the y value, we could plug in. Let's do it if you would like. Don't need to do this, but might as well. We're here. So e to the natural log of 2. So this base of e, right, when they have a big base and a little base are the same, it's actually just equal to that number up there. So the y equals 2. So the y value is 2. The reason I don't need to do that or don't care about that is because since we're revolving around the x-axis, I just care about the x coordinates for these 2 points. So my integral is going to be 0 to the natural log of 2. All right, so to find the volume, I'm going to put that pi out front. And remember, you take your function, which is e to the power of x, and we are going to square it, right? That would give us the area. Remember, think of like squared units for area. We integrate that to go backwards to get the volume. All right, so I'm going to clean that up a little bit. Get e to the 2x power. All right, we actually just did this one where you copy it down. It just had the letter y. Put the 1/2 in front, evaluate it at 0, and the natural log of 2. So f of the natural log of 2 minus f of 0. And yes, we will multiply everything by pi. So 1/2 times e raised to 2 times the natural log of 2 power minus 1/2 e raised to the 2 times 0 power. All right, let's look a little bit at this, just e 2 times the natural log of 2 power. So what I do is I move this to the back to become a power. All right, so it's the natural log of 2 squared, which is actually the natural log of 4. And just like I did up here, so I guess I'm kind of glad I did it first up here. Remember, if the big base e and the little base match, then it's just going to be equal to 4. All right, now I don't write 4 because that's just, this is 4. Half of 4 would be 2. And then this is going to be e to the 0 power, which is 1. Right, e to the 0 power is 1, so that's minus 1/2. So I have 4/2 minus 1/2, which is 3/2. Don't forget to multiply by pi. So 3/2 times pi is 3 pi over 2. So that's 16. All right, let's do 17. Okay, 17 has a region in the first quadrant. We'll sketch it, bounded by this square root function, the x-axis, and a vertical line. Which of the following integrals gives the volume of the solid generated about the y-axis? All right, so the moment I read y-axis, I'm thinking in my integral, I better see dy. Don't see dy on those two. So don't even really know a whole lot. If you know you need to see dy when you revolve around a vertical axis, then you know you have 50-50 shot here. So let's sketch it. All right, we've got, when I plug in 0, 0 minus 1 is a negative 1. I can't do 0. I can do 1 though, right? 1 square root of 1 is 0. Then I'm going to do 5. We'll see in a moment why I chose these numbers. And then I'll do 10. 5 minus 1 is 4. Square root of 4 is 2. 10 minus 1 is 3. Or excuse me, 9. Square root of 9 is 3. So here is this one here. And then we have our line, x equals 10, which is this line right here. All right, so that's x equals 10. Now, remember we are revolving this area, so this is our region R, around the vertical axis, which is the y-axis here. And when we did this in Delta Math, we said that you find the distance from the axis of revolution to the farthest one first, right? So that'd be 0 minus 10, all of that squared. And then negative 10 squared is just 100. All right, and then that's going to be minus the distance from the axis of revolution, so the y-axis, 0 minus our closer one, which is going to be this square root function. All right, so you'll notice in both of these answer choices, you have the whole number first, which makes sense. We talked about that. All right, and you probably already see what the answer is right now. Just to make sure you're on the same page, right? This ordered pair is 1, 0. This one is 10, 3. So that's why you see 0 to 3. So D is the answer. But let's make sure you know why they used y squared plus 1. So if I rewrite, so copy this down. If I rewrite this, I'm going to square both sides. And then I'm going to move the minus 1 over with addition. All right, and so that's how they get the y squared plus 1, all of that squared. All right, so again, it's one of those things where you probably could have answered this without fully knowing everything, but I wanted to go over all of it so you know why they're setting it up like that. Okay, so that's 17. Okay, 18. The base of a solid is the region of the first quadrant bounded by the graph y equals 2x minus x squared and the x-axis. So let's sketch this. All right, so first quadrant, so 0 is going to be 0. Plug in 1. 2 times 1 is 2, and then 1 squared is 1, so 2 minus 1 is going to be 1. So 1, 1. Let's plug in 2. 2 times 2 is 4, and then 2 squared is 4, 4 minus 4 is 0. So actually, this is it, right? The rest of the function is going to keep going down. All right, so I only care about this region right here, and it tells us that we are going to look at it in terms of a cross section to the x-axis perpendicular to the x-axis is a square. So what I think is, if you think about taking little tiny pieces, right? So I'm going to take like this tiny piece right here, and this is a square. All right. We want to try to find the area of all of these little tiny squares, and then we take the sum of those and we integrate to find the volume. So what we do is, this is why I want to go over these. We'll do this in class as well. So you do the integral from 0 to 2, right? Our x-axis, 0 to 2. And then what we do is, you want to ask yourself, what is the area of this shape? And the area for a square is side squared. All right, now it's kind of hard to see, and I'll try to do my best in class. But when I look at this length of this side, right, this one in green now, the length of this side is going to be from the x-axis to our function. So that distance, since I don't care about positive or negative, is literally just this function. So when I think about finding the area of this square, I'm going to think about doing my function 2x minus x squared, all of that squared dx. So that is how we're going to find the volume here. One thing you should notice is in these problems, if the shape that they choose, right, they chose a square, doesn't have pi in the area, you'll notice pi is not out front. So just be careful with that. And if you look at the answer choices, none of them have pi. That's kind of a giveaway as well. So just be careful. Think about what the shape is. If the area of that shape does not include pi in the formula, then you don't need to worry about having pi in the actual integral. All right, so let's expand 2x minus x squared. So I square 2x and I get 4x squared. Then my middle term is going to be multiplying them. So that's going to be negative 2x cubed. But if you double that, you get negative 4x cubed. And then finally, squaring the opposite of x squared is going to be plus x to the fourth power. So I'm going to write it in order here. All right, and then that's going to be dx, the integral from 0 to 2. So now we integrate 1/5 x to the fifth power minus, let's see, this is going to be, I think, just x to the fourth power. Yes, that's 4x cubed plus, let's see, I need 4/3 x cubed, all evaluated at 0 and 2. Now this one I like because when I plug in 0, I'm just going to get 0, so I just need to plug in 2. So 1/5 times 2 to the fifth power minus 2 to the fourth power plus 4/3 times 2 cubed. All right? So that's going to give me, so I'll go over here to finish. That's going to give me 32/5 minus 16 plus, let's see, 2 cubed is 8. 8 times 4 is 32/3. Okay, let's get a common denominator. I guess the common denominator is going to be 15. So 32 times 3, 30 times 3 is 90, 96/5 minus 16. Let's see, I want to get this to be 15. So let's see. I don't think I did this right. Hold on. Let me pause for a second. Okay, I think I did it right, actually. I just didn't want to put this to be, that should be 15. All right, so let's go and do it. All right, so 16, let's see. 16 times 10 is 160, and then we have, let's see, 16 times 5. What is that going to be? 6 times 5. Okay, that should be 80, so 240, I think. Really making this tougher on myself. That's all right. And then this last one times 5, that's going to be 150 to, so 32 times 5. 30 times 5 is 150, 2 times 5 is 10, so 160. I think this is going to give me the right answer. Let's see. So that's going to give me a negative 80, 96 minus 80. Yeah, we did it. That's 16, 15. So I did get it right. Sorry about that. Just had like a moment of, do I really want to multiply 16 times 15? Sure enough, I did. All right, so that's 18 for that one. All right, 19. We have the base of a solid is the region in the first quadrant. So we'll graph the first quadrant again, and we're doing 0 and 1. All right, let's plot it first. So y cubed, so 0 cubed is 0, 1 cubed is 1, so it looks like this. Right, hopefully you remember how to graph this from your days in algebra. All right, now, one thing I notice is when I look at the cross section here, right, this is the area that I'm looking at. It says a semicircle. Well, that means the area for a semicircle is pi r squared, which is a circle, but we want half of that, okay? And it says that the cross-section perpendicular to it is a semicircle and the base of a solid in the region of the first quadrant. So this whole thing, right, is going to be my semicircle. So the way I think about this is I want to first move the pi over 2 away. And then because I am looking at this whole thing being the semicircle, I need to find the radius. And the radius is actually going to be that distance in half. So I actually have to take this function, which is x cubed, and divide it by 2. So x cubed divided by 2 will be my radius. I need to square that. So let's set this up. Actually, let's do one more step and then I'll set it up. So I have pi over 2. Let's square this. So I get x to the 6th power over 4. Now watch this. See if your brain's good with this. So 0 to 1. All right, I'm going to move the pi over 8 out front. So I took pi over 2 and this 4 down here to make pi over 8 out front and left it as x to the 6th power dx. Integrating that will give me my volume. So I have 1/7 x to the 7th power evaluated at 0 and 1. Again, I don't need to worry about 0. So it's just 1/7 times 1 to the 7th power. So that's just going to be 1/7. But remember, at the end of the day, I still need to multiply by my pi over 8 that's out front. So pi over 8 times 1/7 is going to be pi over 56. And these are the questions that are probably going to be the most missed on the test. So I'll make sure when we go over this in person, really, really, really hit home how to do these, okay? Luckily, the last couple are just like this. All right, or at least this one is. Number 20. Same process, essentially. We're looking at 0 to 1, but with this time we have x squared. So it's going to look like this. Doesn't matter that it's actually, positive in that quadrant because it's very similar in terms of the area. Now, this is the key part. For the solid, each cross-section perpendicular to the x-axis is a quarter circle. All right? Now, watch this. A quarter circle is pi r squared over 4. Now, and here's something that they didn't have on the last one. With the corresponding circle's center on the x-axis and one radius in the xy plane. So that's telling us for this, trying to do this real quick, like that, okay? It's telling us that the distance from the x-axis, right, which is the center of the circle, to my function x squared is the radius. So this time my radius is x squared. The last one, right, the radius was not my function. The radius was my function cut in half, right? So the diameter was my function. But in this one, the radius actually is my function. So when I plug it in, it's going to be pi over 4 times my radius squared. So clean that up. you get pi over 4 times x to the fourth power. So to find the volume, move the pi over 4 in front, going from 0 to 1, and you're going to put x to the fourth power dx. So integrate, you get 1/5 x to the fifth power. Evaluate it at 1 and 0. Again, just like last time, you're just going to need to plug in the 1. 1 to the fifth power is 1. 1 times 1/5 is 1/5. And then don't forget to multiply by that pi over 4 in front. So 1/5 times pi over 4 is pi over 20. So those are going to be, like I said, the most challenging ones. So we'll make sure we go over them, and I'll do my best to help you get those right on the test. Okay, last one. All right, so we got a region bounded in the first quadrant by the graph e to the negative x power. So let's see, e to the 0 power is still going to be 1. Right, so 0, 1. And then e to the first power, right? E to the first power is actually going to be e to the when I plug in 1 for x, it's going to be e to the negative first power, which is 1 over e, and 1 over a bigger number is actually going to end up being a smaller number each time. So let me make sure I show you how to do this in terms of that sketch. All right, because you have to think that it's kind of like the reciprocal here. All right, so e to the negative x power, right, is going to end up getting smaller and smaller, so closer and closer to 0, but never touching it. All right, so it would look like this if you cared about the rest of it, but we just care about the first quadrant. We've got the x-axis, the y-axis, and some line x equals b. I don't know where you want to do that, but let's do it there. X equals b. Okay, it says the cross sections are perpendicular to the x-axis are squares. So that's kind of nice. We already did one like that. So these are going to be squares. So if you zoom in, remember the area for a square is side squared. Okay, and the distance here, right, to get my length of my side is just the function. So my area is going to be e to the negative x power squared. All right, now what makes this one tricky, is that they don't actually give us this value b. We've got to solve for it. So if we set up our equation, we're going to have the integral from 0 to b, right, I don't know, of my function e to the negative x power squared dx. So if we find this, right, ultimately this is going to be equal to 4/9, and then we have to do some algebra to figure out what b is. All right, so let's clean it up. You get e to the negative 2x power. All right, so if I do the antiderivative, I copy it down. Now when I take the derivative of negative 2x, I get negative 2. I don't want that, so I need to do negative reciprocal of that. All right, and then evaluate it at 0 and b. So let's plug in b. Negative 1/2 e to the negative 2b minus negative 1/2 e to the negative 2 times 0 power. All right, so I'm going to leave this alone for a second. And then this right here, see if you're good with this. Anything to the 0, e to the 0 power is 1. That's going to be negative 1/2, but we're subtracting a negative 1/2. So I'm going to write plus 1/2. And remember, all of this is equal to 4/9. So now if I want to do my algebra, I'll come over here so I have more room. Copy it down. I'm going to solve for b. All right, so move the 1/2 over with subtraction. And we want to get a common denominator. So let's get a common denominator of 18. So that's 8/18 minus 9/18, so negative 1/18. Move the negative 1/2 over by multiplying by the reciprocal, so negative 2. Negative times a negative is a positive. 2/18 becomes 1/9. And then this is where I'm going to rewrite this using the natural log, right? This is an exponential function. So the natural log of 1/9 equals negative 2b. Let's see if I like that. No, I don't want to do that. Let's do this. Let's first set this up as a proportion. Here we go. And now we'll cross multiply. So 9 times e to the negative 2b equals 1. I guess we get the same thing. E to the negative 2b power equals 1/9. Take the natural log of both sides. There we go. All right, so then we have e. This little base is e, right? So that's going to end up being just negative 2b when you move it in front. And if you divide both sides by -2, we'll get our answer. All right, now that looks kind of clunky. Let's see if we can figure out what the answer is. Looks like the answer is going to be D. Now let me go back and see where I made my mistake in terms of my math. Hold on one second. Okay, I know what I did. Let me go back before setting up this proportion. I know my mistake. So let's go ahead and rewrite this before I change it, before I cross multiply, as 1 over e to the 2b power. And then you'll get e to the 2b power equals 9. Now we can do our natural log of 9 equals 2b, right? Changing it to be a natural exponential function, written as a logarithm. And then if you divide both sides by 2, you get b is the natural log of 9 over 2. And all they've done instead of dividing by 2 is just put the 1/2 in front. There we go. That makes a lot more sense. All right, so when I get you the live version in class, I'll do a better job of getting that correct the first time. All right, anyway, that's it for this one. Reach out if you have any questions, and good luck on the test.